Now you see the non-vectored interrupts. These do not implicitly mention the ISR, interrupt service routine location in memory. And the vectored ones, they imply the ISR location in their the signal itself. So that means you're issuing an interrupt sequence. It's a bit sequence, obviously. If the bit sequence is not just a it is not just a what can I say? It is not just an interrupt signal, but it also contains the address of where the ISR is located. This happens when different ISRs can be handled, and so it is no point in issuing a signal which has uh, the vector of the subroutine. And if it is a vectored, and if that, then that is called a non-vectored interrupt. And the vectored interrupt, on the other, is bit pattern content exactly. So let's thing is handled by the same program. So some routine, some interrupt is handled by the same program again and again and again. So that way, we can issue a vectored interrupt where immediately, as soon as the interrupt is serviced, the computer will immediately be able to tell that it is a that is to say that it is an implication, it is an implied thing that if you are servicing this particular interrupt, you will have to go to this particular ISR. An example of this is the good example of a vectored interrupt is the 8085 interrupt trap. This is a hardware interrupt. It's a vectored interrupt. It carries with it the location of the interrupt service routine that's going to be serving it, and it is a non-maskable one. It's a priority one interrupt. So for example, on an 8085 or an 8085 like platform where trap or trap like interrupting is possible, then the antivirus would have issued a trap. So I encourage you to please look up the interrupt service routine of 8085 so that you can get a clear view of what I've just discussed and know exactly how a computer architecture deals with interrupts. It's a very important part, obviously, of computer architecture. Without any interrupts, this question of servicing different programs at the same time, well, albeit on a time sharing basis, it's not possible. You might wonder, however, why do we call it vector? In physics, we've all done physics, I'm sure. In physics, the difference between a scalar and a vector is the scalar has magnitude, vector also has direction. So that is from where it comes. You'll find vector as a term in biology and everywhere else. More or less, it means the same thing. In vector, the direction is also given, the direction in which, and in this case, the direction in which the computer control must flow in order to service the particular interrupt. In other words, where the computer must look for the proper interrupt service routine, where in memory the computer must look for the proper uh, interrupt service routine in memory, that is implied, and so that is called, and that is vectored because it contains the direction in which the computer should go. Non-vectored, on the other one, they in the signal itself they don't carry this sense, or in this direction or this position where the computer should start for the interrupt service routine to be properly run, but they will have to be processed further to find out which ISR has to be used. So it's not implied in the control signal itself. That is exactly why these are called non-vectored interrupts, and the other ones where it is implied they're called vectored interrupts.